Alright, so in this problem, I have 2 to the power of x is equal to 5 to the power of x plus 7. So, I actually have 2 methods to solve this problem. So make sure to stick around for the video to see me solve both methods. So for my first method, method 1, I'm going to write my problem right here. 2 to the power of x is equal to 5 to the power of x plus 7. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 5 to the power of x plus 7, I can write that as 5 to the power of x times 5 to the power of 7. And now, from here, I'm going to divide both sides by 5 to the power of x. So then these two cancel out, and I get 2 to the power of x over 5 to the power of x is equal to 5 to the power of 7. Now from here, an important property of exponents is that if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 5 to the power of x is equal to 2 over 5. And another property is that if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 2 over 5 to the power of x. And this is equal to 5 to the power of 7. Now from here, I'm going to take the log on both sides. So I get log 2 over 5 to the power of x is equal to log 5 to the power of 7. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. In this case, I have log 2 over 5 to the power of x, so I can move x to the front, and I have log 5 to the power of 7, so I can move 7 to the front. So I get x times log 2 over 5 is equal to 7 times log 5. Now from here, we obviously want to find the value of x, so to do that, we have to get rid of log 2 over 5 by dividing both sides by log 2 over 5. So then these two cancel out, and I get x is equal to 7 times log 5 over log 2 over 5. And we have our answer here. This is our solution, but there is a way to simplify it more. So first off, if I have something in the form log a over b, this is equal to log a minus log b. So log 2 over 5, that's going to equal log 2 minus log 5. And now from here, I get 7 times log 5 over log 2 minus log 7 times log 5 over log 5. And these two cancel out, so I get 7 times log 5 over log 2 minus 7. And this is the same thing as 7 of log base 2 of 5 minus 7. Now for method 2, what I can do is, my equation was 2 to the power of x is equal to 5 to the power of x plus 7. And now I'm going to just start by taking the log on both sides. So I get log 2 to the power of x is equal to log 5 to the power of x plus 7. And now using that property, I get x times log 2 is equal to x plus 7 times log 5. And now if I distribute the log 5, I get x times log 2 is equal to x times log 5 plus 7 times log 5. Now if I subtract x times log 5 on both sides, these two cancel out and I get x times log 2 minus x times log 5 is equal to 7 times log 5. Now I can factor out x, so I get x times log 2 minus log 5 is equal to 7 times log 5. And divide log 2 minus log 5 on both sides. So these two cancel out and I get x is equal to 7 times log 5 over log 2 minus log 5, which again simplifies to this. So x equals 7 times log base 2 of 5 minus 7 is my answer. Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem.